A particle P travels in a straight line. The velocity of P at time t seconds is v meters per second, where v is equal to this. Find the acceleration of P at time t is equal to 4. Now there is a rule, I'll write it down, SVA. If you move down, this will be differentiation. If you move up, this will be integration. Now S is represented for the equation of displacement, V is represented for the equation of velocity, and A is represented for the equation of acceleration. Now we have an equation for V and we have to find acceleration. So going from velocity to acceleration, we have to differentiate. So acceleration will be equal to, differentiation of t is 1 minus 7 multiplied by half into t, and we have to subtract 1 from power, minus half, and 12t becomes 0. In this equation, if you just put 4 in the place of t, let me just write it down. 1 minus 7 into half into 4 raised to power minus half. This will give you an acceleration at t is equal to 4, which will be minus 3 by 4 meters per second square. Find the value of t at which p is at instantaneous rest. Now instantaneously at rest, it means v is equal to 0. So we'll just equate the original equation, this equation, to 0. So 0 is equal to t minus 7t raised to power half plus 12. Now we can use a substitution method here. Let's say t is equal to x square, and if you take square root on both sides, t raised to power half is equal to x. So t is equal to x square, 0 is equal to x square minus 7 times t raised to power half is x plus 12. Now this is a quadratic equation. If you solve this, you will get x is equal to 3 and x is equal to 4. But we have to find t. So we'll convert it back, and we know that for x is equal to 3, if we square the value, we'll get t. So 3 square is equal to t, which is equal to 9. Similar for 4, 4 square is equal to t, which is equal to 16. So at 9th second and 16th second, the particle is at instantaneous rest. Now for the C part, find the total distance traveled by P in the interval of 0 to 25. Now we'll use the same formula, SVA. We have an equation for V and we have to find the distance. So going up, we'll do integration. Now the original equation is V is equal to t minus 7t raised to power half plus 12, and we have to integrate this equation. Now for t will become t square divided by 2 minus 7t raised to power 3 by 2 divided by 3 by 2 plus 12t. Now this equation is integrated. Now what we have to do is, we'll integrate this equation in 3 parts. Why? Because there in the B part, we have found that on 9th second and 16th second, the velocity is equal to 0. So in distance time graph, let's suppose this is the graph. Okay, so in this graph the particle may have gone like this. This may be the 9th second, this may be the 16th second. Now if you find distance of this and this both parts in one go, you will get a wrong answer, because here in the 9th second and on the 16th second the velocity is 0. So you will find the distance from 0 to 9th second, 9th to 16th second, and 16th to onward 25th second for the complete distance traveled by the particle P. So the equation will be t square divided by 2 minus 7t raised to power 3 by 2 divided by 3 by 2 plus 12t. The limits for this will be 0 to 9. Then add the same equation but change the limit. T square divided by 2 minus 7t raised to power 3 by 2 divided by 3 by 2 plus 12t. Now use the limits 9 to 16 and then plus the final part, t square divided by 2 minus 7t raised to power 3 by 2 divided by 3 by 2 plus 12t, and the final limits are 16 to 25. Now solve these equations with these limits, you will get your answer as 31.5 meters.